Now the next example for solving quadratic equations that we're going to talk about is called the method of isolating the square. And this method will be useful for quadratic equations that are missing the x term. And what we'll do in general is this. We're going to isolate the x squared term. We're going to take the constant term to the other side, then take the square root of both sides, then we have the solutions to the equation. So for our first example, we have x squared minus 16 is equal to 0. Now, this should look familiar to you because we solved this earlier by the factoring method. So what we'll do is to add 16 to both sides, isolating the x squared term. Now we'd like to take the square root of both sides, and the square root of x squared, I think you recall, is equal to x. Now when we take the square root of 16, we want to be sure that we get both the positive and the negative square root of 16 because we want both solutions to the equation. So we're going to write in more compact form the positive and negative sign like this. So can you see that it's a combination of a plus sign and a negative sign? So then simplifying, we see we have then the positive and negative 4. And we could also write this then as x equals 4, or x then is equal to negative 4 if we'd like to write the solutions separately. Now in a similar way, we'll solve the equation x squared minus 17 is equal to 0. So we'll isolate the squared term, add 17 to both sides. Taking the square root of both sides, we have then x is equal to positive and negative the square root of 17. And we can't really simplify the square root of 17 anymore, but what we could do is find to leave the answer the way it is, or we could write the solution separately by saying x is equal to the square root of 17, or x is equal to negative the square root of 17.